In this video, we're going to discuss how to evaluate the derivatives of some more complex functions using the product rule. So, we would use the product rule whenever a function takes the form f at x times g at x, or y at x equals f at x times g at x. Now, before we continue, at this point you should be relatively comfortable with the power rule and also differentiating trigonometric functions, so evaluating the derivatives of trigonometric functions. If you aren't quite comfortable with those yet, I've made some videos for the different trigonometric functions, so I recommend you check those ones out before moving on with this video here. So essentially, whenever we're evaluating a derivative of a function that takes the form y at x equals f at x times g at x, the derivative is f at x prime, f prime at x times g at x plus g prime at x times f at x. So to get a better understanding of how this works, let's do this in an example. So let's say we have a function h at x is equal to x squared cos, so my pad's acting up here, cos 3x Alright, so how do we evaluate this derivative here? Well, we notice that we notice two things right away. We notice one thing right away, and that is there are basically two separate functions here. Okay, so it's just one function times another. So in order to evaluate those derivatives, we can look at it like this. We can call this one f at x, and then we can call this g at x. G at x. All right, and then from that point on, we would just go on and evaluate the integral, or excuse me, the derivative using this format here. So h prime at x is equal to f at x, or f prime at x times g at x. So f prime at x, okay, the derivative of x squared is 2x. Times g at x, which is cos x, or cos 3x. Pen's a little bit sluggish. Plus g prime at x, okay, so the derivative of cos 3x, which we know to be negative sine 3x times 3 times f at x times 2x times 2x. Or sorry, x squared, my bad, x squared. So from here, we can go on and simplify this. So we will write it as 2x, okay, 2x cos 3x minus, and then we'll multiply the 3 and the x squared together, so 3x squared sine 3x. Right, and there's your product rule. All right, let's do another example here. So let's say we're given the following function. Okay, we're given a function y at x is equal to sine 2x cos x. All right, what would the derivative of this be? Well, as you can see here, we have two terms, sine x, or a different color here. Oh, we have sine x, and then we have cos x here, like so. So what we can do is we can look at one of these as f at x, and we can look at the other one as g at x. And from this point on, we would just evaluate this derivative according to this format here. So we would write h prime at x is equal to the derivative of f at x. Okay, so the derivative of sine 2x is going to be cos 2x times 2. Okay, that's the derivative of f at x. And I'm going to multiply that by g at x, which is this right here, which is just cos x. Plus the derivative of g at x, okay, the derivative of g at x, so the derivative of cos x, which is negative sine x, times 1. And then I'm going to multiply that by f at x, which is sine 2x, times sine 2x. Alrighty, and there you have it. So what we can do now is we can even simplify this further. So we can write 2 times cos 2x times cos x minus sine x times sine 2x. Make that look a little bit neater here. Sine 2x. And there you have it. So that is the product rule. So in the next video, we're going to discuss the quotient rule.